Good afternoon and welcome to this session. First, I do hope with the current climate everyone is managing to stay safe. And although this session is virtual, we will be on hand at the end to answer any questions you may have. Just to introduce myself, my name is Demir and I'm one of the technical specialists at Autodesk looking after the product design and manufacturing platform. So why is this presentation called The Art of the Possible? The purpose of this overview is to demonstrate how companies such as yourselves can introduce a connected workflow from the initial project definition all the way through to the release of information to the customer. To walk you through what we often see within organizations that we speak to as their typical product development process, which I'm going to be using as the basis for the rest of this presentation. With every product development process, it starts by identifying a market need. And once this concept work is at a suitable level, design engineers then develop a solution to a point whereby they can pass it on to manufacturing, often using lots of different iterations until they're confident and comfortable that they've addressed the initial requirement. Manufacturing engineers then utilize this data as the basis to generate information necessary to actually manufacture the product, often with changes that are required to make it to a suitable quantity and quality. This product then moves into sales where they need to sell at a suitable price to make sure it's profitable. And eventually this product goes out into the market where customers may come back to the original organization for servicing requirements, or ultimately that product will go end of life and the customer will then come back into the market looking for a replacement. But as you can see, this is a very linear process and companies often focus on individual stages and technology to solve those challenges they face. But companies that are looking at individual technologies often will solve one issue but cause challenges in other parts of the process. So how can companies do what they need to do but increase the value of their offering and differentiate themselves in the market? By changing the value proposition, offering things like mass customization enables companies to offer best fit solutions where possible, which is something you often see in the automotive space. This lets engineers focus on the value-add tasks, such as engineer to order. Involving customers early and getting them involved in the development process often results in them buying into your offering. It can also help solve issues sooner. Then when we look at flexible manufacturing, whether this is streamlining the design workflow for subtractive manufacturing, utilizing additive approaches to develop more innovative products, or developing a hybrid approach to utilize both additive and subtractive for complex designs, or by developing a process that allows you to manufacture at the point of demand. Again, changing the traditional linear process and thinking more about what you can do to add value to you as a business and the customers that you supply. All of this enables greater opportunity for a unique customer experience. This is more than just a buy and sell relationship, differentiating yourselves in the market. And then with data at the center, it allows you to get feedback from the field, helping product development and allowing the organization to resolve issues proactively, all of which results in greater value to the customer and more likely repeat business to those organizations that you deal with. As I mentioned, organizations relying on a linear process often experience the challenge that this type of workflow results in information being reworked, information lost, errors, and productivity wasted. In fact, when we look at a company that already has various technologies in place, they often still fall back to manual processes to communicate and share with other parties. In the UK alone, when we run discovery surveys for our customers, their teams often come back and tell us that on average they're spending 21.5 hours per person per week on activities that just don't add value to their design, engineering, manufacturing and delivery process. Obviously, it can include activities such as email communication, but there's always a significant amount of time and effort lost when they try and deliver their projects. As you can see, based upon the previous example, we don't expect to come in and disrupt an organization's workflow to streamline it. What we want to do is help these organizations to resolve their barriers and challenges by developing a connected, streamlined workflow that we call a digital strategy template. Because by having a strategy, you have a better chance of success. By the end of this presentation, what we'd like you to be thinking about is, where are you today? Where do you want to be? And what's stopping you getting there? So let's take a look at a set of examples that can be used to help you develop an end-to-end workflow. We're basing these set of examples on a customer that has two types of product. One mainstream, customers that can choose a set of options to ultimately choose and select the product they wish to purchase. The other, something that is engineered to order. Roughly, often 80% standard and 20% that requires an engineer's input to develop a solution to. So what we're looking at first is this idea of a configure to order workflow. Customer interactions that need to be able to utilize the engineering logic that you built into your products, but make it available much earlier on in the process, enabling your engineers to spend more time and effort working on things that are more profitable. What you're seeing on the screen here is the engineering data with a certain amount of logic built into it. But this product isn't something that needs to be re-engineered every time a variation occurs. In fact, the organization has defined all the predefined options that a customer can select. Obviously, this product needs to be manufactured in the first place, and we need fabrication details to suit. But by making this data available for your customers or your sales teams, it means you as a design and manufacturing organization can spend more time on the profitable undertakings. By making this standard application available in a customer environment, as you're seeing, it means the customer can get an understanding of what's input into that design, what they can choose from, what it looks like, what it might be broken down into, and select the various options that you've allowed them to dictate. Once these options have been defined, they can then submit either a request for a more accurate quote, or in this example, you can see once the customers place the inputs, they can then define the sort of feedback they want to receive. For example, what type of outputs they might want to utilize and communicate with. Whether that's just the 3D representation of the design, or elements such as the cost, the bill of materials, and anything else that you want to allow them to have access to. Again, making it a much more streamlined workflow because your customers are gaining access to this information, and often customers will make their buying decisions before they've even spoken to you. So by making this information much more available, much earlier on in the process, means some of the hard work has been already done when that customer contacts you for the final order, for example. And as you can see here, by allowing them to download additional file formats, it's giving them access to information that they can supply to you to make it much easier for you to understand what it is that they want. However, not every project can be just made available on a website for a customer to interact with. Your engineers are still there to undertake the value-add tasks. So, how do we define what those engineers are doing, what current work is in place, and what information we need to capture from the sales teams? By utilizing an upfront workflow, being able to capture the requirements upfront means everyone in the business that has access knows where that project is, what the requirements are for that project, and where they are currently within that process. This example is showing you how a design manager or someone in the business that needs to make the decisions can understand how many projects we've got going on, who's undertaking those projects, and whereabouts are we within that process. By capturing the information that's been defined up front means instantly they can get an understanding of maybe who's got the headroom to undertake the next task, how much effort is going to be required to deliver that project, where are we within the timelines of that project. But the real benefit here is we've got a controlled way of driving the next process. When the engineering manager in this scenario understands all the requirements have been met, they can then move the workflow on to the next process. The design engineer is then going to be notified that something has been generated for them to undertake, but also the downstream benefit of what you're seeing here is an environment has been created in the design environment that means they don't have to sit there and think about what's the project definition, who's asked for it, what's the numbering schemes we're going to use. The structure that the engineer is going to undertake and work in has already been predefined, and it's now down to the design engineer to undertake the work that they can achieve. Now, I mentioned right at the beginning that most organizations, even if their product is engineered to order, there is often a heavy element of reuse. 80% in this scenario may be standard and 20% will be re-engineered to suit a new customer requirement. So the design engineers need an environment that allows them to quickly find and reuse to generate that new development. What you're going to see next is how the design engineer can find the relevant information very quickly, being able to filter across all the previous projects that they may have undertaken based upon certain criteria that they know. In this case, it might be a description and a material specification, but instantly they get an understanding of the impact of any change. At the same moment in time, they can understand the complexities of everything that goes into that design, while also getting a feel for what it previously looked like. But because this is going to be an engineered to order solution, they're going to reuse as much as possible and copy the elements that they're allowed to modify and manipulate. What you're seeing here is the engineer not just pre-selecting the information that they're going to reuse, but defining the data that will be copied with a new numbering scheme that they're then going to utilize to develop that new project definition. This then becomes the start point for everything they will do moving forward. The downstream advantage is all the hard work has been done. There may be engineering logic that's already applicable to the design, but they want to limit what an engineer or a designer can change. You're also seeing here that the designer can get a very quick appreciation for the amount of information that they can actually modify. In this case, being able to see what's still locked down because we just reused it, and what information is available for me to edit and change based upon the controls that are in place. Remember, we've already undertaken the project and we are making changes to it. So there is already a whole host of engineering logic that the original designer has implemented within that portfolio of applications and products. What you're seeing next is how we can utilize some of the design standards that you can build your own logic into your product to enable your design engineers not just to quickly reuse, but to manipulate this product to suit a new project requirement. Because we have that 80-20% rule, we're going to use the existing project as the basis for a new design. However, there is a whole host of intelligence already within that initial design. So the designer in this particular example is actually making changes based upon previous definitions within the remit of what they're allowed to do. Don't forget, this is pretty much that 80% of change. We're just changing things that I'm allowed to change. I'm not necessarily reworking a lot of these items yet. However, once we've done the basics, not only is our drawing going to update automatically, but then we can spend more time working on the elements that need re-engineering. So once we have the basis for this new product, we can then send this back into our data management environment for the next person to undertake the task that they need to. Now, when information needs to be generated, we often find that organizations have a whole host of data available in lots of different formats. Often this could be information that was archived a number of years ago, so it doesn't even exist within a CAD environment. What you're going to see next is how we can take information that's been previously archived and utilize that in an intelligent fashion to be able to give us that kickstart into designing a new component. Here you can see just a PDF file of a previous design that has been archived away a number of years ago. But because we can manage it, we can find it quite quickly and decide whether it's suitable for reuse. What you may not have noticed there is I brought that PDF file into a 2D environment that turned it into an intelligent set of information that I could utilize. We can then reference that data inside of our model environment. So it means that rather than me having to create information from scratch or refer to prints that I'm going to utilize off my desk, I can start consuming the information that's now in intelligent format to develop our new component. In this case, it's going to be the shaft to support the trowel subassembly of this design. But because we're working in a common 3D environment, we can get an understanding of the form and the function of that design, even though this started off life as a straightforward PDF document. Once we've developed this component to a suitable level of detail, we can then have an understanding of how heavy it is if we specify a specific material. Or if there's other information that we need to consume, such as different orthographic views, there's nothing stopping you just reusing that information time and time again, applying the mechanical detail that's appropriate to manufacture this element. In this scenario, you can see that we're referencing the same information time and time again, in this case to develop an alternative location of features on the design. However, everything is associated back to that 2D data where we consumed the PDF file. So I don't have to generate a new subset of 2D documentation because so far we haven't actually made any changes. We're just developing a 3D form that we can then utilize to understand, is that going to fit? But don't forget, we have turned this into an intelligent 2D drawing. So if a design change is required, we can go back into that 2D environment, make our change, and see the impact of what we've done in our 3D world. Again, giving the user ultimate flexibility to consume information from lots and lots of different sources. We often appreciate that a lot of customers struggle to collaborate. They often resort back to traditional methods such as email, imagery, static, 2D drawings, and PDFs to communicate their designs. What you're going to see next is how we've given our users the capability to be able to collaborate, not just in a secure fashion, but give their users a unique experience that allow them to explore the products before you've made them real. We also often find that depending on the level of technical ability within organizations, that people can misinterpret 2D drawings. In the past, organizations, when they're producing documentation, purely rely on 2D drawings to communicate their product design downstream. Now we can take that and make it in a much more flexible manner, much easier to consume. You should be seeing on the screen that we're not just relying on 2D drawings and documentation to generate the information necessary to manufacture this part. We're adding 3D annotations. We're consuming dimensions that were developed within the modeling environment to overview what that component should be manufactured like, what tapped holes are applicable to it, what face finish if we want to, what tolerances are applicable to that design. Once we then start communicating that design, a customer or someone internal or external with a secure link can then start interrogating that model based upon the information that you've shared. They can start pulling it apart, turning things on and off, and getting a much better understanding of what your intention of that design was there to address. But it also gives them the ability to be able to comment and mark up. In this scenario, they've been able to see that a challenge may have occurred based upon something that I've overlooked. So being able to collaborate on any web-enabled device means that you can get feedback from the field, from third parties, as long as they've got access to the internet. The one benefit of what you're seeing here is not are they just marking it up and applying comments to the design that I've shared, but as a user within my CAD environment, I'm getting to see that feedback. I'm not having to go and try and interpret imagery or static documents that may have been marked up. I can understand natively based upon the information I initially shared any comments that are applicable to what I want to achieve. We also appreciate when you're communicating with third parties, and when I say third parties, it could be a supplier, it could be someone else in your business, or it could be your customer delivering data in another file format. We often find organizations aren't lucky enough to be working with one platform with one version of that platform. We often find that you're having to consume information from lots and lots of different other software vendors' file formats. So what customers need to do to remove that barrier and rework of information is to be able to consume that data as easily as possible. So within the design environment that we work within, we can work with information across the majority of manufacturing suppliers. In this case, you can see how we've referenced a SolidWorks model because the supplier of this engine is utilizing another platform. But when I reference this design, because I'm not translating it, I'm just referring back to the original, we can see that there's a problem. The supplier's given us something that isn't suitable for our design. And what we need to do is tell them that a change is required. Utilizing the workflow you saw a moment ago, we've been able to communicate back with the supplier, make it really obvious what changes are required. And by consuming information via the cloud, they've been able to supply the data back to us in a connected workflow that means we can see and understand the changes that they've made. By consuming that information and utilizing it, we can now understand how it all fits together. And we've been able to work in a really collaborative method with people that don't necessarily have access to the same tools as us. Once we've positioned the component, we can then start understanding, are there any other possible challenges or issues that may be applicable to this design? And as you can see here, by running a quick analysis of any clash, we can now understand that although we've asked for one change, the reality is the adapter plate or other aspects around that mating condition needs to be modified. Again, working in this complete cycle of review, we're able to communicate, our customer or supplier in this scenario is able to understand, and they can then pass any changes back on to us so we can understand the impact. Again, working in that complete loop that allows you to remove the barriers of rework, be able to make you more productive and deliver information to, in this scenario, production much faster than in the past. Now, when design engineers are working and developing their products, they need to have an understanding of what challenges they may face downstream based upon the tolerances that you've applied. So within the same environment, utilizing the same information you've seen throughout, design engineers have a great deal of flexibility to be able to analyze and interpret the overall impact of elements that have gone into their product design. What you're seeing here is the information that we actually applied earlier on. We've got the overall tolerance analysis of the design. What you're seeing here is a 1D stack up. The user has been able to define what direction they want to look for any tolerance challenges. The system will then come back with all the information that could have an overall impact on the end conditions. What you're also seeing here is the user can start interacting with that information, understanding the worst case scenario, any statistical reports they want to understand. And the reason this is important is if you can imagine, we can understand that the overall impact of all the tolerances within our design will actually make our mechanism outside of scope and a change may be required. We can provide the report and the evidence of why that information needs to change because it will not meet the overall conditions and scope of the design that we're introducing to the market. Something that a lot of customers take for granted is the ability to be able to analyze. Now, we speak to lots of different organizations that utilize different platforms and different methodologies to bring their product to market. Depending on what industry you're in, you may rely on a third party to code check your design, and that's still valid. However, we often see that organizations struggle to make changes based upon feedback they're receiving from people that are analyzing their designs. What we want to introduce is the ability for designers to be able to iterate their product iterate their challenges before necessarily passing that on to another third party for final verification and validation. But remember, we reused a previous design, and that previous design has already been validated, but we have been making changes to that design. So within the same environment, the user, the designer in this scenario, can start verifying and validating what they see, what it fits like, what stresses and motions are applicable to it, and has any changes within their undertaking impacted their final result. So without the user having to do a great deal, in this scenario, change the motion load based upon the new motor that was inserted into our design, they can have an understanding of what sort of impact that new motion load will have on their overall design work, and the changes need to be made to overcome the overall safety factor, the deflection that's appropriate for quality, or anything else that's appropriate to that design. And because we have the logic built into this component, we can start making changes based upon what we're allowed to modify. In this scenario, you can even see that we can quickly rerun the analysis without having to go back into the environment, because we've already done it once. We've made changes to the design, and we just want to see what changes and how they impact the overall output. In this case, you can see that we've significantly improved the overall deflection, and we're now within the quality aspects of what we want to address and deliver to our overall solution. Now, when it comes to communicating with your customer, we talked about customer experience right at the beginning. And one of the ways you can improve customer experience is getting that person into the room or understanding what it is that you're developing before you physically cut any material. Now, in the past, organizations have often relied on rendering capabilities to show them more realistic imagery of what that overall concept will look like before a physical item is produced. However, we can now take that one step further. Whether it's building a customer's confidence in what it is you're trying to develop and providing an interactive way for them to see all the possible options in a more realistic manner. But it's also developing a more immersive environment where they can see in front of their own eyes what it looks like and understand how it works. So not only can we start interacting with this like a point of sale tool, we can start immersing ourselves in a virtual reality world where we can see the overall size and envelope that we're working with, where we can start interacting with those options you saw a moment ago, whether that's just so they get a better look and feel of the understanding of the material finish or anything else that's appropriate to that design. By immersing themselves in the real world, not only does it give you the ability to have a better appreciation of that product, but it also means you get an understanding of the overall size, not the look, but the overall aesthetics of what that will look like. And in this scenario, you can even start producing technical information, whether that's the ability for someone to be able to immerse themselves in an assembly instruction, a maintenance manual, or even putting tools into their hands so they get an understanding of how much space they've got to work with if they've got to maintain a product. What's the overall health and safety requirements if they're moving between equipment? But again, we can also mix reality. We might be in virtual reality, but we can start connecting the virtual world with the physical world. Not only seeing how this component and product's going to look like, but controlling it with a physical controller. So although they're in a virtual world, they're physically working with the controller that could be utilized to maneuver this design. Again, bringing in that customer experience and offering something that a lot of your competitors are unlikely to be doing right now. We often will be speaking with organizations who are aware of a lot of the capabilities that are coming onto the market. Now, a few years ago, Autodesk introduced generative design. Generative design is something that allows you, the designer, the ability to be able to define what sort of load conditions and envelope a component might be expected to work within. And then rather than a designer trying to develop individual iterations, which are often limited by time, so even when they are iterating different forms, they might be limited to no more than a handful because time often dictates that a designer can't spend overly excessive amounts of time developing a solution. Wouldn't it be great if a designer could define the outline, submit the overall project to the cloud, utilize the power of the infinite computing power of the cloud to come back with lots of variations in the form that a designer can then select based upon the material characteristics, the manufacturing selection, or even the safety factor to come out with a form that they may not have been able to think of using their traditional techniques. What you're seeing here is the results of that generative design. The user being able to select based upon what they know and their knowledge to find something that's suitable for what they want as an outcome. In this scenario, not only is the product significantly lighter weight than what they've done in the past, but it's also stronger. And it might be using a more additive approach, but it again allows them to develop a project that's maybe more aesthetically pleasing, but certainly unique if they were to compare themselves against their competitors' offering. When it comes to manufacturing, we again see that even if an organization has the ability to be able to drive their machine tools, they're often thinking about how can we best communicate information between the design environment and the manufacturing environment, often working in disconnected systems, which means rework can be quite time-consuming, and any changes that are made need to be re-engineered within the manufacturing world. What you're seeing here is the same design environment with the manufacturing information completely attached and enclosed within the same window. The design has already been done once, so the original manufacturing information is already captured within that data that we copied. However, there might be information that we've added since that we need to add toolpaths to. So what you're seeing here is us modifying the original toolpath that we copied and adding information to it that now allows me to pass this on to the machining center or for machining verification. But it is fully associated back to the design environment. So if a change is required based upon customer request, all we need to do is go back and make the change, maybe modify the tool paths that are appropriate, in this case the number of drill positions, and everything else will update accordingly. So the outline, the remachining of the adaptive clearing, the material that we need to get rid of to give our final finish is all being updated with a minimal amount of effort. The benefit to organizations is if your design engineers have the knowledge, they can get an understanding of what the change will mean based upon the manufacturing process that we expect, how much time would be added to the overall finishing of this component. We can also see the overall and output the NC code, the G code that's applicable, have an understanding of what setup's required. So the guy in the machining center can understand what tools are required, the order in which they should be placed, and anything else that's appropriate to that machining operation. And finally, what you're seeing here is not only is everything embedded into that one design environment, but all the associative information with it, such as that setup sheet, such as the G code, is being managed in the same environment. So all the engineering data is being captured, saved, and controlled, so anyone with the relevant access can see the right information at the right time. Now, if you can imagine the operator on the machining center has a system with a browser, they can then log in, and as long as they've been given secure access, they can download the design data, download the G code, download the setup sheet, and anything else that's appropriate that's been stored with that one common source of truth. Now, you might not have noticed that the design engineer put the information to review. And what we need is a more flexible way, and what a lot of organizations need is a flexible way for, say, engineering managers to be able to communicate with that team. Maybe approve data on the fly. So what you're seeing here is the design engineer checking information in to the data management system. They're associating any relevant data, in this case, maybe a manual document that's also associative to that design, and they want to make that data available to the rest of the business. But to do so, they need to go through a review process. Now, when this design data goes through the review process, it might be that, especially with the current situation, you're away from the office. As long as you have network access using the mobile device, we can log into the system and start reviewing the data that we've been asked to look at. As you can see here, not only are we checking information out because we've been given the relevant provision and access to be able to do so, but we can also start utilizing the benefits of some of the mobile capabilities to start commenting on the information that's been shared with us. In this case, it's not really meant to be a physical signature, but it is giving a workflow using mobile information to be able to comment and review that data and even start changing the life cycles. So as long as the engineering manager in this scenario has the relevant privileges, they can then move design data through the stages to eventually release this information to the rest of the business. Once this data is then released, we want to start thinking about how can you make more benefit from it? How can you ensure that everyone downstream has got access to the right information? By connecting all of this information through, it helps our customers have that synchronized workflow. Whether they're delivering the data that we produce to a business system, or whether we want to make more intelligent information available to site, so people installing, disassembling, or just doing general service work have something that is of more value to them. So what you're going to see here is two workflows. The first workflow is me making this information available to the rest of the business. To do so, they then push the data into a suitable workflow. In this scenario, what we actually want to do is generate a technical document that allows someone to interact with our 3D design, not just rotate it, not just look at the properties of it, but actually see the sequence of how something should be assembled or disassembled, and maybe annotations that go along with it. By making this data available to the cloud, we can then utilize our cloud platform to build something that's a little bit more interactive. By pulling the components apart in the right sequence, we're not only developing an interactive technical set of information, but we can also deliver this data to our business systems, link it, so anyone with the right level of access can have a better understanding of what should be done when they need to maintain this product. By then delivering this data to our business system, in other words, moving the information from external collaboration into released to manufacture, not only are we locking the design data down so everyone can understand and view the information when it's at the appropriate stage or gate, but this information is now being automatically synchronized to our business system. In this case, our Fusion Lifecycle platform. The real advantage is we can now start taking the design bill of materials and start turning that into a manufacturing bill of materials, adding items such as paint or grease or non-designed elements that still need to be purchased. They still need to be stock controlled. You can also see here all the visuals that are associated to that design are also available within the system without anyone having to go elsewhere, really addressing the data at the center. And finally, what you're also seeing here is how the information such as the technical publication is also associated to that record. So anyone, anywhere in the world that has access to the system that you've allowed them to address the security that you require can now see all the information without user interaction of manually uploading PDF files and anything else that's typically done within a lot of organizations that we speak to in today. The last two aspects of this presentation is, remember we talked about flexible manufacturing. Now you've seen one example where an organization can utilize the embedded capabilities to address their manufacturing needs. In that scenario, it was around subtractive manufacturing. But we talked about automating production. Now that could be utilizing production lines, factories to build your products and optimizing those factories. But in this particular customer example, it was about automating the setup on the machine tool itself. When organizations work within pre-machined stock, it's often quite difficult for them to be able to set that machined stock on the machining center itself because they need to move the origin and everything else that's appropriate to the G-code. What you're seeing in this example is on the left-hand side, the manual setup, and on the right-hand side, using our automated setup capability. Now on the left-hand side, the user of that machining center is having to manually manipulate the stock that's been pre-machined into the relevant position. So when we start machining the final finish, the component and 0, 0 is exactly where I expect it to be. On the right-hand side, with the automated setup, what we're actually doing is placing the stock material anywhere within reason on that machining bed. We're then probing that position and the code is being modified to suit the position on that machining center itself. Now, even if you don't understand some of the aspects around this, what you should be able to appreciate is the amount of time difference it's taken. On the left-hand side, over 15 minutes, and on the right-hand side, under 3 minutes, significantly saving the amount of time it takes to set up that component to start machining it. Again, it's about productivity and making your lives easier. Now, if you can remember those 5 steps, the final step was smart services. Now, this can mean many different things to different people, but ultimately it's about having that agile product development process, the ability to be able to feed back information that may have gone out into the field or maybe going through final quality and assembly on your site. By being able to have data at the center, it means anyone with the appropriate access can start feeding back into the system, helping the next iteration of that design. So what you're seeing here is a change being necessary. Within the system, we can obviously start understanding where we are within any part of the process. We can then start going through design process reviews. In this scenario, we're allocating time and pushing something to the next stage. That next stage might be someone within the business that needs to review or inspect the final finished product. Or it might even be in a customer environment where you'd like to introduce a connected workflow that allows them to feed back anything that they see in the field. Now, it's a very visual workflow, what you're seeing here, because we've built an environment where users can log in and start interacting with the design data you saw earlier in a much more visual and more impactful way. Being able to address, comment, but ultimately connect back into that feedback loop. So by introducing these comments, what we're actually doing is applying information to the design review. That design review will also then trigger a change request. So as you can see, once the information is passed on by that third party, back within our business system, not only will we be notified of the changes that have been raised, but we can then start controlling what do we do with it. Is it really a necessary change? Is there really been a mistake? Or is it just that the customer needs an alternative for the next time we go through that design iteration process? In this case, the customer actually requested that we start thinking about an electric start. So we do want to raise the design revision and start thinking about how we can iterate the next development process of our products. And again, it's about having that agile feedback loop, about ensuring that we've got availability and visibility of everything that's going on and control of who sees what when, but also where we are in that process and what trigger points do we need to undertake the next task. Now, I appreciate we've only had a short amount of time to go through this presentation, this content, and there is a lot, but I wanted to highlight and prove to you what we're doing for organizations such as yourselves to be able to connect that workflow from end to end. And the collection that we've gone through there gives you the ability to be able to take your product from start to finish. However, there are a whole host of aspects that I haven't been able to cover in today's presentation. So please bear in mind, this is just a small snapshot of some of the capabilities that you can address with today's platform. And from an Autodesk perspective, we truly believe that we are offering our customers something that is attainable. It's something that you can be up and running with a sensible amount of time. It's also cost effective because, as you should all be aware, we now offer collections. We appreciate that customers will rarely utilize a single application to address every single need they have within their design and manufacturing process. And by having a collection, it gives you the flexibility to utilize the right capability for the right task. Ultimately, because organizations need greater freedom to collaborate and to communicate, again, everything you've seen there is cloud connected, meaning when you want to be able to provide something, a more unique customer experience to get their feedback, or whether you want to make your information available to a greater part of your business, again, you've got a much more flexible capability to do so. Everything we've been talking about has been about productivity, about ensuring that smooth flow of information to ensure that you've got a faster time to market. And ultimately, we've only shown you a small set of examples. There truly is a much more broader capability that allows you to grow and scale as your needs grow as well. So with that, I'd like to say thank you very much for your time and your attention. Really, what are your next steps? Well, obviously, you're on these 2 days trying to get a better understanding of what can be achieved and what other organizations are doing in the same environment or in a similar industry. But what I really do ask you to think about is engaging with us and potentially undertaking something like a discovery survey or a discovery workshop up front, so we can have a better understanding of what it is you're trying to achieve. Where do you want to be, and how do you think, what's stopping you getting there? Ultimately, it allows us the capability to identify what we can do to help, to quantify the value that can be brought, and to obviously justify any expenditure that may be required. So with that, let's say thank you very much once again. And obviously we will be on hand to answer any questions, and I do hope you enjoy the rest of your day. Thank you very much.